Hi dears, welcome to my channel. Today I am taking the topic Class 10 Lesson 2 Acids, Bases and Salts. Okay. First lesson was what ma? Chemical reactions and equations was the first lesson. There I have asked you 3 questions. Do you remember? I have written all these questions in the board and it's the time for answering these questions. The first question, KClO3 when heated we will get KCl and O2. What kind of reaction it is? It's very easy dears. It's break down into two parts. A single one is breaking down. It is decomposition reaction and you have to write it as endothermic reaction because it's absorbing heat energy. Then only the reaction is happening. The second question, lead nitrate plus 2 potassium iodide gives lead iodide plus potassium nitrate. In this, here X and here Y had been given. Means what is it, whether it is a solid or aqueous or liquid or is it precipitate, what it is you have to write over here. X, what is it? It's a solid. Potassium iodide is a solid and KNO3 potassium lead iodide is a solid solid and potassium nitrate is an aqueous medium. It's aqueous, AQ. The third question was titanium chloride TiCl4 plus magnesium. When reacted, we will get titanium and magnesium chloride. Here, they are asking to write it in a balanced form. CCl4, 4 chlorine atoms are used. Here only 2 is there. So what we have to do? We have to add 2 over here. When it is added 2, then see, is there any changes? Has to be made. Here magnesium has become 2. So here only 1 magnesium is there. So we have to add 2 over here. Now see, titanium 1 was there, 1 is there. So no need of adding anything. And Cl4 is there. 2 into 2 gives you 4. And then Mg2, 2 Mg. So the equation is balanced. I think balancing is very thorough with you, isn't it? Now it's the time to start the second lesson, that is acids, bases and salts. The lesson is very interesting. Firstly, I am telling you, don't count the pages. Oh, how much long the lesson is. The children are having the habit of it. How much long the lesson is, how tough the subject will be. You should not count the pages. Learn by understanding. Then it will be very easy for you. Okay, dears? Acids, bases and salts in 8th standard itself, we all are learning about it, isn't it? Which is acid. How can you identify acid? With the case of litmus paper, we are able to identify blue in acid turns red. It's the formula, it is the simple mnemonic which helps you. Blue in acid turns red, like that, okay? And bases red changes to blue, okay, in litmus. And there are natural indicators like turmeric, then what to say, hibiscus, all these we have learned, right? Now we are going to see with the smell can we identify. With the smell can we identify the substance is acid or base. Is it possible? Yes, it is possible. In the case of onion, vanilla and clove. You all know the smell of onion, right? In acid, the smell remains same. If you are keeping a cloth, they are saying like that only. Cut the onion into slices and keep 2 pieces of cloth in it and keep it overnight and take the cloth. The cloth will be having that much smell of onion, right? When we are keeping it in a hydrochloric acid or any acid solution, the smell remains same. Okay? If you are taking that cloth and if you are putting it in a base, sodium hydroxide or whatever base it is, the smell will not be felt even. The smell will be disappeared. So the same for vanilla. Vanilla smell everyone likes it, right? And for clove also, clove smell is also good. And in these 3 cases, when we are taking the cloth and the smell is there in it, if you are keeping in acid solution, the smell remains same. And if you are keeping it in base solution, the smell will be disappeared. This kind of indicators are called olfactory indicators. What's that? Olfactory indicators. Okay. Now we are going to see some reaction of acids and base with metal oxide, all these things, metal carbonates, metal hydrocarbons, all these. Okay, dears? First, acid or base when react with a metal. Kind of what is metal? Metal cereals. Everyone should have this with you. Okay, dears? Everyone should have this. What is this, ma? This is the periodic table which helps you for finding what are metals, what are non-metals and all. See, ma? Here, these all are what, ma? Metals. These all metals. All these will be metal. We can treat all these as metals. Yes, here all, up to here. We can consider it as metals because what are the specialty of the metals? Metals are able to lose electron. They are capable of losing electron. They are called metals. What about non-metals, ma? They will take electrons from others because they will be having negative charge and the metals will be having positive charge. Let's see what is the reaction of acid and base in metal. Are you ready, dears? Okay. Acid or base when react with metal, we will get salt as well as hydrogen gas. Hydrogen gas will be evolved. Okay, when the acid or a base reacts with metal. Here, magnesium. Here, acid, in the case of acid, I am using HCl. HCl is an acid? Yes, hydrochloric acid. When react with magnesium, what you have to write? Hydrogen is evolved. So, hydrogen will be free. Make it free. What is the rest? What is the rest, dears? Mg and Cl. Mg. Can you write MgCl? No, MgCl2. Because magnesium is having +2 oxidation state. +2 means it is able to lose 2 electrons. While chlorine is able to take only 1 electron. So how many chlorine should be there? 2 electrons can be lost by magnesium. But 1 electron can be received by chlorine. So in the case of 2 magnesium which is losing 1 chlorine in one place. So the other should be 1 more chlorine should be there. That's why it is called MgCl2. Okay? MgCl2 plus hydrogen. Similarly for the bases, sodium hydroxide is a base, isn't it? When react with zinc, zinc is also, we have seen, right? Zinc, isn't it? Zinc is here. Okay, when reacted with zinc, what we have to take? We have to take hydrogen separately. H2 has been gone and the rest is Na2ZnO2. Sodium zincate is formed. Okay, dears? Now we are moving for the reaction of acids with metal carbonates or metal hydrogen carbonates. What is that? Don't feel afraid when we are saying hydrogen carbonate or this. What is it? Understand. Carbonates means CO3 2 minus. CO3 2 minus means negative charge 2 minus 2 is the negative charge of it and CO3. CO3 2 minus is carbonates. Hydrogen carbonate means one hydrogen will be added here. Negative 2 will be changed to negative 1. Did you get, ma? HCO3 minus. HCO3 minus. This is what? Hydrogen carbonate. What they are reacting? They are reacting with acids. There should be something there. CO3 2 minus is there. No, there should be a metal because metal is the donor. So it has to be taken from the metal. Okay, now you tell me. When it is taken from this group. What is this? Alkali metals. See, lithium, sodium, potassium. Can you see, ma? Lithium, sodium, potassium, rubidium, cesium, francium. Here I am taking sodium. Okay, dear, sodium. What is the charge of sodium? Means it is able to donate how many electrons? Because it's able to donate only 1 electron. Alkali metals, alkaline earth metals, all these. Here, this group can donate only 1 electron. This group can donate how many electrons? 2 electrons. And this group will donate like that. It is moving. So it is able to donate 1 electron only. So here, see, ma, sodium I am adding and CO3. Here 2 minus has to be nullified. So how many sodium has to be added? Sodium is able to donate only 1 electron. Here 2 negative charge has to be nullified. So how many sodium has to be added? 2 Na2CO3. Is it easy? Now react with HCl. What they are saying? Carbon dioxide and water you write. CO2 plus H2O gone. What is the rest? A salt, ma. Carbon dioxide gone. H2O. CO3 from the CO2 has gone and H2O. The reaction is not balanced. That's why H2O will be going. So what will be the rest? Sodium chloride. NaCl, this is the salt, isn't it? Now we are going to balance it. So how can you balance? 2H2Cl. Yes. NaCl. Is it clear for you? NaCl plus CO2 plus H2O. CO2, one oxygen is remaining. 2 hydrogen is there. Okay. Then 2. So here will be what mark? 2 NaCl. 2 NaCl plus CO2 plus H2O. Is the equation balanced? Yes, the equation is also balanced. This is how the metal carbonates reacts with what? Acid. Metal hydrogen carbonate means what? Hydrogen will be added over here. That is, if you are taking the same sodium, see Na, NaHCO3. Is there any need of one more sodium here? No, because it's having only -1. Here sodium is able to give 1 plus 1. So NaHCO3 plus same HCl. Gives what ma? H2O has been already written ma. Plus carbon dioxide. Then what? Then the same. Sodium chloride. Then you have to balance the equation. All this you have to do. See dears, here also carbon dioxide and water is liberated along with the salt. Okay dears. Now, how will you identify this is carbon dioxide, salt is evolved? Which gas it is? How can you understand? Here we are going to bubble in calcium hydroxide. Do you remember calcium hydroxide slated line? When we are bubbling it, carbon dioxide, what will we get? Calcium carbonate. Okay? We are getting calcium carbonate. CaOH twice plus CO2. What will we get, ma? Calcium CO3 plus water. Did you get? This is the equation. Now this is the reaction of metal carbonates and hydrogen carbonate with. See, now we are going to see the reaction of acid and a base. What will happen if an acid and a base reacts with each other? Okay, what is a strong acid? Hydrochloric acid, sulfuric acid, nitric acid. We have all the three acids. Hydrochloric, nitric and sulfuric are considered to be the strong acids. Okay. King of chemicals. What is that? Sulfuric acid is the king of chemicals. Okay. Now, any acid, okay, reacts with a base. Consider it as hydrochloric acid, HCl. Plus base. What is the base? Any base, can you say? Sodium hydroxide. NaOH. What we will get? We will get salt as well as water. It's very easy, dears. I will teach you how to do. NaCl, NaOH and HCl, right? I am writing in this manner. ClH. HCl I am just making it ulta, that's all, okay? NaOH I am writing it as OH Na. Can I write like this? Just for understanding I am writing. Here H and OH got joined and become what, ma? H2O. H and OH joined to form H2O. So what is left? Sodium and chlorine. So it is NaCl. It's the easy way for understanding. Okay dears? Acid plus base gives salt as well as water. That means HOH has been taken away and the rest of all became the salt. It's easy, isn't it? Now we are going to see the reaction of metal oxides with acids. Metal oxide. Don't be afraid. Metal oxides means any metal, dears, we know many metals, right? We are having enough metals with us. So see, all these are metals. Any of these metal oxide. For example, there should be an oxygen in the metal. Along with that, an oxygen should be added. Oxygen is able to take 2 electrons. That's why H2O, because oxygen is capable of taking 2 electrons, withdrawing 2 electrons, O2 minus it is. So in the case of alkali metals, what should be added? If sodium I am taking, how many sodium should be there? 1 sodium can give 1 electron. So 2 sodiums can give 2 electrons, which is equal to the oxygen can take 2 electrons. So we are writing Na2O. Na2O. Okay, Na2O react with HCl. HCl is the acid which is very easy for us to understand. That's why HCl all the time I am writing. Okay, it's reacting with acid. What will happen? We are taking water out, H2O plus what? NaCl. Nothing more NaCl. Salt. See dears, the equation is not balanced. It's your duty to make it balanced. Okay? Na2O plus HCl gives NaCl plus H2O. In the case of copper, copper is also a metal. Copper is able to donate 2 electrons and the oxygen will take 2 electrons. So CuO. CuO. This reacts with sulfuric acid. What will we get? What will we get? Copper sulfate, CuSO4. SO4 plus water, H2O. These are the reactions of metal oxides with acids. Now, you tell me whether the metal oxide is acting as a acid or a base. See, salt we are getting. When acid is reacting with what we are getting salt? With the base only. If the acid is reacting with base, we are getting salt. So, metal oxide is acting as an acid or a base? It's acting as a base. Okay, it's acting as a base. Basic oxide we will say. Okay dears. Now, non-metal oxides with base. The reaction of non-metal oxides. What is the meaning of this non-metal oxides? The things which are not metal or non-metal. Non-metal, we know now. What are they? Bromine, boron, carbon, nitrogen, oxygen, fluorine. All these are non-metals. Here we are taking what? We are taking carbon. Carbon along with oxygen. Which one we know? The famous one which we are breathing out. Carbon and oxygen combine together to form carbon dioxide. So carbon dioxide is considered as the non-metal. When react with a base. Base, our base which we are taking as sodium hydroxide always, so that it's easy for you and me to write it. Okay, when reacting with the base, what will happen? Water we are getting first and then sodium and carbon dioxide. This will combine to form carbonate to form Na2CO3, sodium carbonate. This is what we are getting when reaction of non-metals with the base. Now tell me, the non-metal oxide is reacting as what? Is it slightly acidic or is it slightly basic? It's slightly acidic because only when acid react with base we are getting salt. So non-metal oxide carbon dioxide is slightly acidic in nature, while this metal oxide is slightly basic in nature. Now we are going to see what are common in acids and bases. Okay, see, hydrochloric acid, sulfuric acids are 2 acids which I have taken, and the bases are sodium hydroxide, potassium hydroxide, and all. Okay, now when we know that when acid reacts with metal, hydrogen gas is evolved along with a salt, isn't it? So what the thing is happening here is when we are taking dilute hydrochloric acid in a beaker, and when we are keeping 2 iron nails as anode as well as cathode, and a wire is connected and a battery and a bulb is connected, then when we are doing this electrolysis, we can see bulb is glowing. Do you know why? Because of the movement of cations as well as anions. Hydrochloric acid is split into H plus Cl minus. Hydrogen ion, chlorine ion. Okay dears, sulfuric acid adds H plus SO4 2 minus. Similarly, in the case of base, is it a reaction happening? Yes, for base also. It is changes into Na plus and OH minus. Similarly, KOH, K plus and OH minus. Like that. That means the acids and base are able to be split into cations and anions. Okay dears, now we are moving to see the reaction of acid and base with water. Okay, the common acid which we are taken is HCl. Okay dears, HCl plus H2O gives H3O plus Cl minus. What is this called? Hydronium ion. Hydronium ion is formed along with chlorine. Chlorine is as chloride minus Cl minus is formed. Okay, it's very unstable. How H2H3O H3O, how the H3O is formed, do you know? Water when react with H plus will give you H3O. This H plus is very unstable. That's why when reacted with water, we are getting what, ma? H3O plus. Okay. Sodium chloride, the same thing in the case of base. Sodium hydroxide, NaOH. When in the presence of water, what will we get? Na plus OH minus. Here what the thing is happening is, the base will be dissolved in water. The bases which are dissolving in water are called alkalis. Bases which are dissolving in water are called alkalis. Here sodium hydroxide, when we are adding water to it, it dissolves in it to form Na plus and OH minus. Okay. Now, how will be the reaction, dears? How will be the reaction when we are adding water directly in concentrated sulfuric acid? Boom! Burning will be happened. Our face will be blackened because it's highly exothermic reaction. Because the acids are highly concentrated, when we are adding water to it, the reaction will be highly exothermic. The test tube will be broken and there will be sparks even. It's very dangerous for you to do this kind of reaction without the presence of teacher. Okay, dears? Dears, in the periodic table, you may have confusion which is metal, which is non-metal. I am telling you, dears, these things from here, alkali metals, alkaline earth metals, and these transition metals, and up to aluminium, gallium, indium, all these up to this extent we are saying as metals. Okay, dears? Here non-metal, carbon, nitrogen, oxygen, fluorine, neon, this section we are considered as non-metals, and there is a diagonal shape, boron, silicon, arsenic, antimony, tellurium, all these. This is a small section. This is metalloid, or we are saying it as semi-metals. They have the speciality of metals as well as non-metals. We may say it as semi-metals or metalloids. Okay, dears? You should not feel any kind of confusion over here. Only this extent is not metal, to this extent it will go. Okay, dears? Now we used to say about the acid and base, which are strong and which are weak. Actually, we will say that H plus is considered as acidic. But not only H plus, there are many other strong acids. See, HCl, sulfuric acid, nitric acid, hydronium ion, HSO4, HPO4, they are considered to be strong, and the weakness will be seen, and they are considered here negligibly weak acid. Here weak, and here strong. Only OH minus is not the strong base. We can say H2 minus, O2 minus, all these are considered to be. Moreover, when we are adding water to acid or base, which is strong, the amount of H plus or OH minus ions will be less because we are adding more water now. So it will be dilute. So it is the easy way to convert the concentrated acid or base into dilute by adding water. But we should be very cautious, and we have to take all the precautions when we are adding water, because anything may happen. Exothermic, highly exothermic reaction, we have to add drop by drop. Okay, that's right. Now we are moving for the pH. pH means hydrogen ion concentration. We are checking whether it is highly acidic or highly basic and all. Okay, this is pH. pH means, P means potence. Potence means power. Power of hydrogen ion concentration in a particular solution. Whether hydrogen ion concentration is more, it will be what, ma? Highly acidic. If the hydrogen ion concentration is very less, it will be changing from acid to base. Okay, this is called pH. Okay, now we have to see 7. pH is 7. What we are saying? The thing is neutral. That means it is neither acidic nor basic. When it is going from 7 to 0, that is 6, 5, 4, 3, 2, 1, 0, the acidity is much more, acidity is much more, and the things will be, substance will be, or the solution will be highly acidic. Okay, when the pH is moving from 7 to 14, it will be going to be more basic. Understood? Now we are going to see what all things are there. See here, can you see? 0. Can you see, dears? Can you see, ma? Now you can see it. Battery and strong hydrofluoric acid is having pH 0. pH 1 hydrochloric acid. Then lime juice, gastric acid and vinegar pH 2. Like that, when pH up to 7, what is that? Pure water. Pure water is neutral, which is having pH 7. Okay, dears. When we are moving here, Great Salt Lake, milk of magnesia, all these are in pH 10. That means it is starting to be basic. When we are coming down, we can see drain cleaner, bleach. All these are highly alkaline or highly basic. We are understanding from it. Now we are moving to see in what all things which we are eating, whether they are acidic or basic. See, dears? Acid. When it is the case of lemon, it is acidic, dear. pH 2. When it's coming for apple, it's in between 3 to 4, isn't it? When it is come to banana, it is 4 to 5 pH. All the things which we are intaking are maximum acidic, right? Now the water is happier, water is having the pH 7. Now we are moving for baking soda, it's having the pH 8 to 9. That means it is started to be basic, okay? Baking soda. Then ammonia comes in this category. And drain cleaner, pH 14. Okay, dears. So now you are having an idea which is having pH negative, which is having pH which is less than 7 and which is having pH more than 7. All these you are having an idea. Now we have to see in our body what is the pH of our body. Our body's pH is 7 to 7.8. It's can be slightly alkaline or slightly basic. It can be 7.8 only. Rain will be normally having, the rain is a pure water is falling down. So the pH should be 7. If the pH is coming down as 5.6 or 5.7 like that, we are saying it as acid rain. You have heard the word acid rain, no? It's very common. It's very common because of the pollution. The acid rains are happening and it affects plants and all the environment itself. Now we are moving for our inside our body. Saliva is having pH what, ma? Saliva actually it is slightly acidic. You have learned in 8th standard, I think, that it is able to convert starch into sugar to a little extent. Only when it is acidic, it will be able to do it. So saliva is having slightly acidic. So 6.8 it is. Okay. You are heard about tooth decay, right? What is tooth decay actually? How is it happening? When we are not brushing the tooth decay comes, isn't it, dears? Actually, when we are eating sweets and all, after a long time, when we are not brushing, we people will not brush at night, right? So we will be sleeping. So what happens? So our bacteria will come and eat these sweets, isn't it? And it will generate some acids. It will generate the acids and go. And this acid is able to corrode the teeth. How is it corroding? Actually, it is corroding the enamel. Enamel is made of calcium phosphate. Enamel is actually basic. It is calcium phosphate. When this calcium phosphate when acid is acted, what happens? Both of them will react and what will get? Salt and water. Isn't it? So the enamel, how much acid the bacteria is generated, that much acid will react with this enamel, and what will happen? That enamel will be reacted with acid and that much enamel will be lost. That's why our teeth will be getting decay, because enamel will be taken away. So what we have to do? We have to brush our teeth. With what we are brushing our teeth? With our hands? With toothpaste. So now tell me, is the toothpaste acid or base? Toothpaste is a base. So that what will happen? When the acid is reacted, it will react with it and gives out salt as well as water, and when we are washing, all the acids will be removed. Oh, all these things are there inside this toothpick, dears. So we have to brush our teeth, okay, dears, to make our teeth clean and strong. Okay, dears. Now, this acid is used by many animals as well as plants. Honeybee. Honeybee is having some kind of acid. Or we can say ant. Ant is having formic acid with it. When it is biting, what will happen? We will be having irritations, we will be having the pain, isn't it? It's because of the acidic nature. It is present in the sting of ant. Okay? For leaves, some plants, needle plant, it is having some some hairs in its leaf. Here it's not getting. If I'm getting, I will show it to you. Surely. Okay, dears. Needle plant will be having some hairs in it. When we are moving through it or crossing that, what will happen? That brush-like part or this hairs will stung in our legs, and we will be having irritation and pain because of a kind of acid called methanoic acid which it is generating. It is having methanoic acid, makes you feel this irritation and pain and all these. Okay, burping, all these burps will be coming. So what we have to do is we have to clean it with some kind of alkali. Okay, to say caustic soda, baking soda, all these will help you to remove it. Similarly, in the case of our stomach, no? In the stomach, you have learned it in 8th standard, I think. Hydrochloric acid is there, isn't it? For what? For digesting our food. So, when we are not eating for a long time, this acid will be generated, isn't it? So, when we are taking a little food, if the acid is more, we will be having gastric problem. Isn't it? Some burps will be coming, and we will be having some irritation, pain will be there. So we have to take antacid. There are enough antacids. So now tell me, if we are taking antacid, it will be removed, right? So what is antacid actually? It will be a base. It will be a base. When this base is reacting with this hydrochloric acid, it can neutralize it, and what will we get? Salt and water will be there, and the acid will be suppressed by the base. So these are all in the. Now it's the time to see what are the acids which are present in our daily life which we are using. See, vinegar. Say I am having a chart. It will be easy for you to understand. Vinegar. Vinegar contains which acid, ma? Acetic acid. Sour milk. Milk contains lactic acid, isn't it, ma? Oranges, citric acid. Lemon, citric acid, isn't it? Then tamarind, tartaric acid. Then ant sting, I told you already, formic acid is present. Apples, malic acid, and tomatoes, oxalic acid. Means all these, the daily using things are having acidic part more, isn't it? Now, we are going to see about some salts. Salt, when you are saying what is the salt which which is in your mind first? Sodium chloride. Sodium chloride is the salt which we know, isn't it? Sodium chloride is a salt because it is used as stable salt and all. Is sodium chloride only a salt? No, there are many other salts. See, there are many other salts. Now, see, sodium chloride is the first one which has been written. Now, magnesium sulfate, potassium iodide, copper chloride, all these, potassium permanganate, all these are considered to be salt. So, when we are seeing a salt, can you identify from which acid and which base the salt is coming from? Like that, seeing a child, can you identify from which father and mother the child is coming from? Like that only, because acid and base react together to form what? Salt and water. Water we are taking out, and the salt from the. Can you help? I will help you. Sodium chloride, Na plus and Cl minus. Na plus. Along with that OH, we know that acid contain H plus ion and the base contain OH minus ion, isn't it, ma? Na, along with that, Na is plus because it's a metal. Na is plus, and we are adding OH. So what will be that? NaOH is the base, and Cl minus it is. So we are adding H plus along with that. So HCl. So from HCl and NaOH, what came? NaCl came. Is it clear? Okay. Now I am saying potassium iodide. Potassium added Ki. K plus and I minus, isn't it, ma? So K plus along with that, for positive charge we are adding OH minus, isn't it? So KOH, it's the base, and I minus. So we are adding H plus. So HI. Okay, HI. So that's why. So that is that's why we are able to identify from that. For example, sodium nitrate, NaNO3. Na along with that Na is plus. So we have to add what, ma? OH minus. So NaOH has become the base. And NO3. NO3 along with that we are adding H plus. So it will be HNO3, nitric acid. From that this salt came. All these are like this. If they are giving a salt and from which acid and base it is coming, it is the trick for you to understand. Okay. Now we can say, are all the salts neutral? No. The salts can be slightly basic and slightly acidic based on when the strong acid and weak base is reacting. The salt which is formed from that will be slightly acidic. For example, I will tell you, if your teacher is not there in the class and teacher has given a leader, a smart one, not a smart one as the leader, and she has given instructions. If anyone is talking, you have to write the name. So what? You will obey what? You will obey the leader, isn't it? We will not obey. But still I am saying, as we are trying to be good children, we are saying, we will obey the leader. Okay. When the teacher comes, will we obey the leader or will we obey the teacher? Teacher only we will be obeying. Because which is strong, we will be along with that side. Isn't it, Kanna? If the principal come, will we obey teacher or leader or principal? Principal only we will obey in the same manner. Okay. If the acid is strong, the salt will be slightly acidic. If the base is strong, the salt will be slightly basic. Okay. This is the way. Okay. Now we are moving to see. What are things we are getting from salt, the common salt, that is sodium chloride. From sodium chloride we are getting a lot of things. What the thing is, caustic soda is the first one. Caustic soda. When the sodium chloride is dissolved in water, and we are saying it as brine, brine, brine. Okay, when the brine solvent, it is moving for an electrolytic reaction. See, what are the reaction? Sodium chloride when react with water, we are getting sodium hydroxide plus chlorine plus hydrogen. Sodium hydroxide here is caustic soda. Sodium hydroxide is caustic soda. Is the caustic soda, is there any use for the caustic soda? Enough uses are there for the caustic soda. It helps to make soap. It helps to make detergent, and in artificial fiber like rayon, all this we are making with the help of this caustic soda, that is NaOH. The chlorine is liberated, right? This chlorine is reacted with calcium hydroxide. Okay, calcium hydroxide, we are getting calcium oxychloride, CaOCl2, that is calcium oxychloride. We are saying it as bleaching powder. Bleaching powder, you may have heard the word, because it helps for purifying water, isn't it, ma'am? It helps for purifying water, uses for making baking powder, antacid CDS. I am having a chart with me. It will be easy for you. If you are knowing this chart, it will be very easy for you to learn. Because what are the uses of baking soda? The third one. Okay, dears. First we got caustic soda. Then the second one, when we are taking the chlorine and we are reacting with calcium hydroxide, we are getting what, ma'am? Bleaching powder. Okay. Now baking soda. Sodium chloride when react with water and carbon dioxide in the presence of ammonia, what we will get? Ammonium chloride and sodium hydrogen carbonate. Okay, sodium hydrogen carbonate, which we are saying as baking soda. Baking soda, when react with any acid, when it is reacting with any acid, it helps for the liberation of water and carbon dioxide along with sodium salt. So, when react with acid, we will get this fluffy bread, cake, all these we are using baking soda for making all the cakes and making it so fluffy, because we will liberate carbon dioxide. So we are using in these factories and in baking items. Then the fourth one is washing soda. Washing soda. How the washing soda is formed? This our ammonium sodium carbonate which we are getting will be reacted with water. So what will happen? Na2CO3 10 H2O. It is called washing soda. Here I am showing it again. What are the uses of all these has been mentioned here. You can learn it. And the things will be very clear for you. Okay, dears. Now we are moving for plaster of Paris and gypsum. What is the plaster of Paris and gypsum? Calcium sulfate 2H2O is the gypsum, and when we are removing water from it, it will be CaSO4 half H2O. That is plaster of Paris. When this plaster of Paris, when we are adding a little water, it will be so tough and it will convert itself into gypsum, so that it will be helpful for making toys and all the thick items. Plaster of Paris are used for some making some toys, then pots and some decorative items. Plaster of Paris is very common. You have to learn that also. Okay, dears. Now the chapter is almost finished. I am not leaving you. What are things which we have learned in this lesson? We have learned acids, base, salts, then the reaction of acids and bases with metal oxide, non-metal oxides, then carbonates, then hydrogen carbonate. All these we have learned. Then about the pH isn't it now, which is neutral, which is acidic, which is basic, and then about the common which we can see at the household, what all things are present, whether it is acidic or basic, all this we have learned. Now, then we have gone for what? We have gone for the reactions or raw materials, raw material from the salt, what all things which we are able to prepare. Then we have gone for different salts, from which acid and base the salt came from. All this we have gone, right? It's the time for you for the questions, to answer these questions. The question, are you ready now? The question starts now. Calcium phosphate is present in tooth enamel. Its nature is dash, whether it is acidic or basic. Calcium phosphate is present in our tooth enamel, whether it is acidic or basic. Second one, dash is used in making glass and soap. Dash is used for making glass as well as soap. Third question, sour of curd. Sour taste of curd is due to dash acid. Sour taste of curd is due to dash acid. Answer these questions. I will meet you